This is Brian Murray and I want to welcome you to another episode of Doc Bry, the Physics Guy. Hi everyone and welcome to my latest blog on quasars. When I was younger, it was the quasar that made the papers much in the same way that black holes tend to now. Over the years though, the light of quasars began to dim as the light of the black hole intensified, and these days they seem to be hardly ever mentioned, which is odd because they're still out there. And the latest thinking from astrophysicists is that each quasar is actually a supermassive black hole. If theories are correct, these black holes have a mass ranging from hundreds of millions to billions of our sun, our solar mass. The quasar was and still is one of the greats of the heavens. The stats for these fellas is truly awe-inspiring. In fact, the numbers are so large that they really are way beyond comprehension. A quasar, quasi-stellar radio source to give it its full title, are really energetic light sources thought to be billions of light years away. To give you some idea of how bright these objects are, consider this if you can. The sun is about 8 light minutes away. It takes light about 8 minutes to travel the 150 million kilometres from the sun to the earth. The nearest star is Alpha Centauri, which is about 4 light years away. It's so far that it's seen as a star, one amongst many. Granted, it's a little brighter than most, but it's just what we would call a regular star all the same. Now, if a quasar was 33 light years away, 8 times the distance of Alpha Centauri, it would still burn so bright as to be almost indistinguishable from the sun on a sunny day. It's thought to be as bright as 2 trillion suns. 2 trillion. This is one of those numbers that's just too large to grasp. I mean, it's genuinely massive. The sun itself radiates an incredible amount of energy every second of every day, and yet a quasar takes this to an entirely different level. To try and give you some idea, think of this. A year is about 31 million seconds. Multiply that by 65,000 and you're around 2 trillion. Okay? So a quasar gives off the same amount of light in 1 second, as our sun does in 65,000 years. I mean, that is huge. The equivalent amount of energy is 65,000 years of our sun, and it does that every second. Now, we've estimated that the sun emits around about 3 times 10 to the 31 joules of energy every second. I mean, that's a massive number. And this amount of energy using E equals mc squared is the same as about 3.6 times 10 to the 14 kilograms, or about 100 billion tonnes. So that's 100 billion tonnes of mass being converted into pure energy every second. That is our sun. In 65,000 years, this amounts to the mass of 12 Earths. In other words, if we could convert the entire Earth into pure energy, then it would be enough energy to keep a quasar going for less than 1/10 of a second. That's about 700 Earths a minute. I mean, talk about greedy. Apart from the 0.1 seconds, which is actually over really quickly, the rest of the numbers I've just discussed are beyond our comprehension. Suffice to say that they're just huge. Okay, so we know that a quasar is running on super high octane. We also know that they're not that big. Though once again, this is a relative thing. They're thought to be about the size of our solar system, which, let's be honest, is pretty big. But considering how bright they burn, it's a small volume. There's about 200,000 known quasars, and most appear to be upwards of 3 billion light years away. The furthest are upwards of 10 billion light years. If the Big Bang Theory is correct, then these older quasars formed about 3 billion years after the start of the universe. In 2017, a quasar was reported that's thought to have originated around 680 million years after the Big Bang. Quasars were first detected in the 1950s and measured using the Doppler effect, and they've been shown to be moving away from us at a tremendous rate, around about 37% of the speed of light. I mean, these things are just moving so fast. Now, for several years after the discovery, many theories were tried to explain the brightness, antimatter or white holes, though it's now thought that it's due to an accretion disk energy mechanism. This is like a big donut that goes round your black hole. And it's thought that at the centre of each quasar is this supermassive black hole. It's also thought by some that most galaxies, including our own Milky Way, have gone through a quasar stage and are now quiet because they've run out of energy. They've no longer got the juice to feed the central black hole to generate radiation. Now, I'm not entirely convinced by the existence of black holes, so I don't agree with some of this. That said, I do like the idea that our galaxy was once a quasar. It's nice to think that our galaxy really was a bright shining object back in the day. I was brought up on quasars, and what's so cool about them is that there's no doubt they exist. You can see them with a telescope. I mean, they really are beautiful, and they're just fantastic and utterly magnificent. Recently though, I read something that's really given me pause for thought, and it's a work of a guy called Alton Harp. I don't know if this guy's right or wrong. Time will no doubt tell. His story though is so interesting that I've done a post on Harp elsewhere. If Harp's right, and I have no idea if he is, then what we think of quasars may turn out to be wrong, and it'll totally change the way that we actually look at the universe. Is he right? Is he wrong? I don't know. Who knows? It might be you who helped figure that one out. This is Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, can you share it with your friends, your fellow students, and anyone you think might be interested? That'd be great, and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news, and check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com. drbry.com. I look forward to seeing you soon.